Hi and welcome back. So in this video, we are going to start writing our function inside our AES service. Actually, the first thing to do, we are going to know how to create a key to start encrypting or decrypting our packets or our text or files, stuff like that. So first thing is a function to generate a key for us. I'll write generate key, and inside this function I'll have key length, and it's going to return a secret key for me, secret key. And the next function is going to be how to convert a key to a string to store it. That's the way I'll always use. It will get a secret key and return a string. And then the next one is how to convert string or our key to the real secret key. It's going to get the key of type string and return the secret key. Simple as that. So let's go to the implementation class, which is here. I'll implement these functions. I'll override them here like this. So to generate a key, we are going to need a key generator. Val key generator. It's going to be of type key generator of JavaX crypto, and then you'll use the get instance objects of type AES. So you will see we have a key generator of type AES algorithm. So first we need to init or initialize our key generator. We'll pass the key length to it and then return the key generator dot generate key. Okay, so now to convert our key to a string, we simply return the base 64 of java.util get encoder that encode to string and pass secret key that's encoded. And for the reverse function, we simply use the decoded bytes is equal to base 64 that get decoder and decodes the key, the string that we are passing, and we have to create a secret key spec now of type JavaX crypto.spec and pass decoded bytes to it. Also, we are going to need a symmetric algorithm. So I'll create it up here, private val, symmetric algorithm. It's going to be AES with CPC, and actually let me copy and paste it here. PKC S5 padding, some secure path for our AES symmetric algorithm, and using that you will create a secret key spec. You can see you will have a secret key here. So using these two functions, we are able to convert our class to a string and return it back to the secret key again. So right now, let's go back to our AES service again and create the functions that actually are in charge to convert our text to an encrypted string and then convert it back to a normal string. So it's going to be a suspend function of type. It's going to be a suspend function called encrypt text. It will get the text of type string and then get the key of type secret key, and it's going to return a nullable string for us. So in case that we run to trouble, we will return null, and then if it doesn't, it will return our string, our encrypted string back. So let's create the other function called decrypt text. We'll need the encrypted text as a string here, and then the key of type secret key, and it's also going to return a nullable string for us again. So let's implement these two inside our implementation class like that. To start working with our encryption or decryption, we're going to need an object called cipher. So let's create the cipher object. It's going to be of type javax.crypto. You'll have cipher.getInstance and then pass the symmetric algorithm to it. So to start encrypted text, we are going to use coroutine to switch to other threads rather than our main thread to stop freezing. So using with context of dispatchers.default, which is responsible for our big calculation. So for now, let's return some stupid string here to get rid of this red line. So first of all, we will init our cipher to cipher.encrypt mode and then pass the key that we are going to work with to it. And then we want to encrypt our text. So encrypted bytes is equal to, I'll wrap it inside a try catch block. In case of any exception, I'll print the stack trace here and then I'll return at the with context with null. And here I'll use the cipher dot to final and pass text to byte array. So using this to final and converting our text to byte arrays, we will have the encrypted bytes here. And down below, we will have the IV, which stands for initial vector, that I'll explain in a moment. And then if we didn't return here, which means we have the IV, and we also have to concat this IV with encrypted bytes together and return as the string, as the encrypted string actually. So combinated IV and encrypted data is equal to IV plus encrypted bytes. Or we can actually just combine it. And then using base 64 class again, that gets encoder and encode it to string and pass combined IV and encrypted data to create an encoded base 64 string for us. So what we did, we switched to the default dispatcher using Kotlin coroutine, initialized our cipher to encrypt mode and pass the key to it, then convert our text that is going to be encrypted to byte array and pass to this function to final, and then we will receive the encrypted bytes here. But for IV, let me explain to you that what IV is. Actually, in cryptography, IV stands for initialization vector. It's a critical component in the cipher block chaining, or CBC here in this padding. When using the advanced encryption standard of AES. In shorthand, it's actually a non-secret, a random value that used to ensure that identical plain text encrypts to different ciphertexts, and it must be unique and unpredictable for each encryption session, and it should be also transmitted alongside with the ciphertext. The thing that we have done here, we will always concat this with our encrypted bytes and pass it to the targets to our friends as the encrypted text. And depending in our algorithm, the IV size is always the same. So if you're wondering how we can then extract this IV here and encrypted bytes later, I have to tell you that using this algorithm, our IV size is actually 16 here. So let's go to the decrypted text and work with it to check if it's working fine or not. So it's going to be same like the encrypt text. We will use the with context with the dispatchers.default. Let's return some text here for now. And then we will extract the IV and decoded data. So decoded data is equal to base 64. We will first decode it to the bytes. The string that is being encrypted here, we have to decode it to the bytes. gets decoder and decode and pass the encrypted text to it. Now let's separate the IV and the encrypted data. So the IV is equal to arrays class that's copy or copy of range. Let's go from decoded data, index of 0 and IV size. And then for encrypted bytes, encrypted bytes is equal to arrays.copy of range. Again, we'll pass decoded data, and for the start index, we'll pass IV size and then decoded data dot size for the last index. So using these two lines, we'll extract the IV and the encrypted bytes that we concatenated before. So right here, we'll use the cipher and initialize it again and set it to decrypt mode and pass the key to it. And also we have to give IV parameter spec and give IV to it. And then let's actually retrieve the original text. We are going to decrypt the text right here. So while decrypted text is equal to try catch. In case of getting any exception, we will print the stack trace and then return null. And also we can actually return from the whole block. And inside here, we will use cipher that's do final and give encrypted bytes to it, and then return a string, actually return this as string. So you will see we will have a notable string here, and then we will return it here. Okay, so test this functionality inside our main activity. Actually create a button here, and using onClick, we will use the functionality to test our AES encryption. So we'll create a text here called click, and then we will pass the session of type crypto session here. Here we have the session. Okay, so on each click, we will create a key session that gets AES, generate key with the length of, let's go with 60, or let's make it bigger, 128. First, we wanna log our key. It's going to be something like this. Let me implement this log here. Okay, so on each click, we will print out our key, and then we will have a text to encrypt, which is going to be hello world, I'm here. And then we will encrypt this text using this key. So while encrypted text is equal to session gets AES service encrypt text, and for the text we'll pass text to encrypt, and for the key we will pass the key that we have created before. But this one is actually assessment function, so let's create a coroutine scope of type remember coroutine scope. Let's move it up here, and using this coroutine scope we'll launch a block and encrypt this text. So we will log D that encrypted text is equal to encrypted text, and then we are going to decrypt this text to a normal text that it was before. So we have the key here as well. So while decrypted text is equal to session.getAESService.decrypt text. So encrypted text is going to be this one, and the key is going to be the key that we had before. So we should mark this as not null, so we know it's going to work. If it doesn't, we have to know that it has to actually throw an exception. So we will mark it as non-null and then log it back again. Decrypted text is equal to decrypted text. So let's run our application and check if it's working fine, and remove this preview actually. So let's open up the logcat, add our tag to it, click. You can see this is our key object that actually we are printing it. We can use actually our session.getAESService.convert key to string and pass the key to it and run it back again. So if I press it, you can see it's our key. It's just a plain string, and this is our encrypted text that we were using before. And actually this one is the decrypted text that we successfully made it back from this encrypted to value that it was before. So that's it for AES text encryption. In the next video, we will learn how to encrypt our file actually to another file and then decrypt it back to the original one. So till the next video, see you everyone.